Hi, this is Thomas Pond, and this is a project on simple harmonic motion. The idea of simple harmonic motion was proposed by French mathematician Joseph Fourier in 1822. The idea of harmonic motion is stating that an object or an oscillator, like a pendulum, would follow a path where each side of the path would be equal distance, and the acceleration would be pointed towards the position of equilibrium. Another example of simple harmonic motion would be the Earth revolving around the Sun. Because the Earth would be following an equal path around the Sun and would begin at the same place where it would end and would follow that path continuously. Now back onto the pendulum, there's different parts of the pendulum which can be described as different things, like the amount of time it takes for an oscillator to go from one position to the other position to go back to the original position is called a period. A period is the amount of time it takes to complete one cycle. And this period is represented with a big T and is measured in seconds. Now, the amount of oscillations per second is known as frequency, which is measured as 1 over T and is measured in hertz. It is inversely proportional to the period, which means that if you were given the frequency instead of the period, you could find the period using the equation 1 over frequency. Now, if you weren't given the time it took at all, but you were given the length of the string here, as let's say 4 meters, you could find the period by using the equation T equals 2 pi times the square root of the length of the string divided by the gravity. And let's say this is on Earth, the gravity would be 10 meters per second squared. To solve this out, you would sub in the length and gravity in the equation like so. So it'd be T equals 2 pi times the square root of the length, which is 4 meters, divided by the gravity. Now, if we plug this into a calculator, we'll find that it'll equal T equals 2 pi times the square root of 0.4, which would then equal 3.97 seconds. And if we wanted to find the frequency, we would do frequency equals 1 over T, or frequency equals 1 over 3.97 seconds, which would then equal 0.25 hertz, which basically says that it would complete 0.25 or a quarter of the entire cycle every second. Now, if you were given a problem that they only gave you the period and you were asked to find the length of the string, you could set it up in an equation like so. So let's say we have the oscillator. Make sure you draw the problem or draw the picture of the problem before solving. It makes it 100 times easier. Then draw a picture, and we want to find the length of the string. But if this problem was on Earth, we know that the gravity equals 10 meters per second squared. To find the length is a little bit tricky. If we were told that the period was 3 seconds, all we would have to do is rearrange the equation to solve for length. And we would do that like so. And t equals 2 pi times square root of the length over gravity. What we want to do is we want to isolate the length. So to do that, we would divide both sides by 2 pi. We'd get the square root of L over G equals T over 2 pi. Then we want to square both sides. So we'd get L over G equals T over 2 pi squared. And then we would multiply both sides by the gravity, and we'd get L equals T over 2 pi squared times the gravity. And then you'd plug in and solve. So if we plugged in, we'd find that L equals 3 divided by 2 pi squared times 10 meters per second squared. And the length of the wire would be approximately 221.84 meters. All right, thank you for tuning in. Signing out.